in physics, that is heat. So before getting into the topic, let me do a small correction in the last class. I have given that the height of the flight is measured by altimeter. I have given the spelling as altimeter, but it is not altimeter, it is altimeter. And while giving this while we're discussing about the barometer, 760 tars, I have given like 1.03 into 10 power 5 pascals. This mistake was done, but in the next immediate line I gave that the bar is nothing but 10 power 5 pascals, like if you have observed. So these are two print mistakes what what was happened in the last class. So please make a correction over there. Now we'll be discussing about the heat. And so what is heat? Heat is a form of energy. Generally it causes sense of touch to us. It's a simple layman definition that is what required for us. And if you see the important property of heat, heat flows from hot body to cold body when they are in contact. Generally, heat flows from hot body to cold body, not from cold body to hot body. So, and this is what the important thing we need to note down. And generally, heat energy is known as thermal energy. And the important thing we need to know about is Newton's law of cooling. This law of cooling says that the rate of cooling of a body is directly proportional to the difference between the temperature of the body and the temperature of the surroundings. Rate of cooling not only depends on the difference between the temperature and also the temperature surroundings also. Yeah, if the difference is more, if the temperature of the body is more and the difference is more, then the body cools fast. So you see an example here. When the hot water is cooled from 95 degrees to 90 degrees, it takes less time rather than cooling from 35 degrees to 30 degrees centigrade. This is the best example that we can see. And if you can see another example, you take two bottles of water, one is hot water, one is cold water. You put those two bottles in refrigerator and you see which one is cooling faster. See, if you can observe, hot water bottle will be cooling very faster as compared to the cold water. This is what Newton's law of cooling explains. If the body temperature is high, then the rate of cooling is very high. That is what it says. And if you see some of the important facts about the heat content of a body is always measured by calorimeter. Don't confuse the temperature and the heat. Temperature is a different thing. That is like thermometer. And here it is a heat content of a body is measured by the calorimeter. And the study of heat, generally it is called calorimetry. And the study of heat and temperature. See here, the study of heat and as well as temperature and the relation with energy and work is called thermodynamics. This is the latest trend in physics, thermodynamics. And the instrument used to measure the low temperature at the poles is called cryometer. At poles we know that here you'll be having very low temperatures, and the instrument which is used to measure these low temperatures, so that is called a cryometer. And the study of low temperatures is nothing but a cryometry. And you see this fuels like cryogenics. You might have heard the name called cryogenics. In rocket the fuel is used. And this cryogenics deals with the study of fuels at very low temperatures. At very low temperatures, whatever is a fuel is there, the study of those fuels is called cryogenics. And you know that cryogenic fuel of rocket, that is nothing but liquid hydrogen and liquid oxygen. This is very important. And the heat energy is measured in calories in CGL systems. If you see CGL system, it is measured in calories. And we know this thing, in MK system, it is joules. And 1 calorie is equal to 4.184 joules. And 1 kilocalorie is nothing but 4,184 joules. This is a very important thing about the heat, friends. What the important fact we need to remember is heat flows from hot body to cold body. And let us see what is temperature. Temperature is nothing but the degree of hotness or coldness of a body. At what degree this body is hot, how hot the body is, how cold the body is, that is called the temperature. And this concept of temperature initially was given by R.H. Fowler. Is the scientist. R.H. Fowler is given the concept of temperature. And in CGL system the temperature is measured in Celsius, and in MK system it is measured in Kelvin. Don't think that C is nothing but Celsius. No, this is, that C is nothing but centimeters. It is Celsius or centigrade. You can call any of them. And MK is measured in Kelvins. And one more thing we need to know is absolute zero temperature. And absolute temperature is nothing but the lowest possible temperature attained by a body. What is the lowest maximum? What is the least temperature that a body can acquire? That is called the absolute zero temperature. And generally it is equal to 0 Kelvin. Absolute zero temperature, we say it is equal to 0 Kelvin. And 0 Kelvin is nothing but a minus 273.15 degrees centigrade. If you see the relation between degrees and Kelvins, this is given as minus 273 degrees centigrade is equal to 1 Kelvin. 1 Kelvin is nothing but minus 273 degree C, and K minus 270, like you can remember like this, like K minus 273 is nothing but centigrade. I give an example over here so that you can understand. Like if see if say temperature is like Celsius, 100 degrees Celsius, then what is in terms of Kelvin? Kelvin is nothing but, you know, that Kelvin minus 273 is nothing but 100. So Kelvin becomes like if 273 goes that side, it will become 373. So 100 degrees centigrade is nothing but 373 Kelvin. This is how you find out the degrees and as well as kelvins. K minus 273 is nothing but C. And like, you know, that freezing point of water or the melting point, like what is the freezing point of water? That is nothing but 0 degrees centigrade. Like you put 0 degrees centigrade, so that K like it will become 273 K. And boiling point of water, you know, that is nothing but 100 degrees centigrade, that is nothing but 373 Kelvin. And if you see the temperature of a healthy human, like that is nothing but 36.9 degrees centigrade. This is the temperature of body temperature of a healthy human. So that if you can convert into kelvins, it will become 309.9 Kelvin. And the daytime temperature on the moon is nothing but 100 degrees centigrade, that is 373 Kelvin. And you know, pasteurization of milk, that is carried out at 67 degrees centigrade. Like you can, if you can convert it in terms of kelvins, it is nothing but 340 kelvins. So this is what about the temperature, friends. Like the things you need to know, like important over here is like the different, like a relation between degrees and Kelvin, that is nothing but K minus 273 is nothing but C. Yeah, now we'll see about thermal conductors. So what are these thermal conductors? Thermal conductors are nothing but the metals or alloys which conduct heat through them. Like, it's very simple. Like the which alloys, like metals or alloys, anything like which can conduct heat through them is called a thermal conductor. Like this is a technical definition what we are giving here. Like example, metals, alloys, mica, etc. Like whichever is allows heat to pass through them, that is called a thermal conductor. See here, it is not temperature, it is heat. Yeah, conductor, like the metal having maximum thermal conductivity is silver, and the liquid metal having maximum thermal conductivity is mercury. See, it is a liquid metal. Mercury is the only liquid metal, and the metal having maximum thermal conductor is silver. Like remember these two things, like metal having maximum thermal conductivity is silver, and liquid metal having thermal conductivity is nothing but mercury. And if you see mica, this is a good thermal conductor and it's a bad electrical conductor, and it can resist up to 1000 degrees Celsius. That is the reason it is mostly used in the manufacture of electric appliances. Like in electric appliances, what happens, like you need to, like in electric appliances, what should happen is like electricity should pass through. Like if this electricity produces heat and the material used, if it cannot resist like that heat, then there is a chance that the wire or the instrument which is passing the electricity may burn. So like in order to prevent this burning, like what they use is like mica is used in electric manufacturers, electric appliances, because like it can resist up to maximum 1000 degrees Celsius. Like this, you can imagine 1000 degrees Celsius is huge. Like so it's a good thermal conductor. It passes it passes like heat through them, so that is called thermal conductor, and it's a bad electrical conductor, and moreover is it does not pass electricity through it. So that is the reason mica is used as a in most of the electric appliances. And if you know, if you see one of the important fact about mica, and in India produces 90% of the world's mica. You keep it in mind, like India produces 90% of the world's mica. So in the world, like 90% of the mica is produced from India only. Now we'll see thermal insulators. So this thermal insulator is exactly opposite to the thermal conductors. Whereas thermal conductors have allowed heat to pass through them, but thermal insulators does not allow heat to pass through them. The best examples you can see is like wood, rubber, glass, plastic, bakelite, thermocol, PVC, and sawdust, etc. See, like you can see in the juice shops, like ice is like covered with sawdust, and also sometimes they will be kept in thermocol boxes. And if you see the importance of PVC, that is nothing but polyvinyl chloride, like electric wires. So those are covered with this polyvinyl chlorides, so that it does not allow heat to come out, because it's an insulator. And wood also used, and glass also used. So you can see the examples here, like domestic electric cables are lined with PVC, that is what I have explained. and air, water and ice are poor conductors of it, and these are the poor conductors of it. Like ice is very poor conductor of it. That is the reason like snow mountains, like they does not allow that whatever the heat is like whatever the radiation they get by the sun, that does not when it falls on the mountains, like these mountains, like the snow does not allow this heat to pass through it. That is the reason like snow mountains does not melt quickly. They melt but not as like as quickly as possible. And also one other reason is like these are very shining in nature, so it reflects like 70 to 80% of the like heat whatever is fall on it. So that is the reason like these snow mountains does not melt quickly. And also like Eskimos like live in igloos. Like igloos are made up of like uh, ice blocks. So these ice blocks, like once igloo is made, like this does not pass, like whatever is heat is inside, that does not pass to go this heat outside. So that is the reason like igloos are warm inside. And ice blocks are covered with sawdust, and because sawdust is an insulator of it, the freezing point of water we know that that's 0 degrees. Like if you increase the pressure, the melting point or the freezing point both are same, these two are same, of ice decreases, so like ice melts very quickly. And if you want to join two ice blocks like together, so what happens, like before looking into this, one more point we'll see here. And when an ice block is placed on a table, like it melts, like when it is when it's placed on a table, like it melts, but don't think that it is melting from the top, but it is melting from the bottom, because it's there is increase in pressure. So once the pressure is increased, like ice melts very quickly. When you want to join two ice blocks, that the process is called relegation. Then how the process works, the process works like this thing, like what happens, like with the placing of two together, like pressure is increased, then immediately after this, like boiling point decreases, and immediately that water like this ice blocks will melt, and this part it is melt and it is formed as liquid. This process takes it for few seconds. Then immediately what happens, like the temperature reaches to 0 degrees Celsius. 0 degrees Celsius means you know that the solidification takes place. This is how it works. Initially water forms, then those two will melt. And you know that in juice centers what happens, like this ice is like stroked with a hammer, because like pressure will be increased, so that ice melts very quickly. And some of the important properties we need to know about the heat, that is one is conduction, second one is convection, and as well as radiation. So conduction is nothing but transfer of heat in a in matter, like without transfer of matter. See here, like you take a rod, you heat the rod, what happens, like heat will pass, but not like the particles of rod will not this rod will not if it is in this shape, and rod, if you are heating, like this will not be, like form like this. Only heat will form, heat will go like this, but not the shape of the rod will be same. That is what the transfer of matter does not takes place. So it is what the conduction is, like only transfer of heat will be there. It takes place generally only in solids. This is the best example. See here, like here the rod is heated, and you can feel that heat with your hand also. That is what conduction is. And the second one is convection. So what is convection? Convection is nothing but transfer of heat followed by transfer of matter. Here matter is also transferred. See that if you see, like air generally, like you see the best example of air. Air generally flows from what, like high pressure region to low pressure region, high pressure to low pressure. So and if the temperature is low, then the high pressure temperature is low means, like you can see that pressure will be high. If temperature is high, like you can see that like pressure will be low. And generally what happens, like cool air comes into the room through windows, like means like when the temperature is cool, that like outside when the temperature is cool, what happens, like pressure will be increased, so that the air will come into our room. And whereas in our room, the room will be warmer and pressure will be low. So immediately once this cool air comes, like what happens, like this high whatever the air is present, already present in our room, that will go out. So see here, like the temperature is coming in and it is sending out some air. So here change of temperature is taking place, as well as change of matter is also taking place. So that is what convection is. And you know the sea breezes, like generally sea breezes you can find in daytime. This is one question is asked in exam. Sea breezes you can find in daytime, land breezes you can find in night time. So because this is a specific heat of, this is due to the specific heat of water and specific heat of land. Generally land heats very quickly, whereas water cooks very slowly. So in daytime what happens is land cooks land heats very quickly. So once the land heats very quickly, the air also heats very quickly. So once the air is very hot, this is called, you can see that this is a low pressure, you can see low pressure. Whereas at the same time what happens in the oceans or seas, so here the temperature will be low as compared to the land. So when the temperature is low means, you can say that it's a high pressure region. So high pressure region, always air flows from high pressure to low pressure. So this is how you can feel some of the air coming from some of the breezes coming from sea. So this is what takes place in daytime. So that is daytime sea breezes takes place. The same opposite process will happen in the time of night. So at the time of night what happens, land cools very fast. So you can see that here you can see high pressure, and whereas water cools very slowly. So means it will be warm. Warm means you can see that low pressure. So at night time air flows from land to sea, ocean. So that is called land breezes. So sea breezes forms at daytime and land breezes forms at night time. So because specific heat of land means, what is the specific heat? Specific heat is the temperature required to heat one volume of content, whatever it is, matter. So that is called specific heat. We'll be discussing in the topic. And this is what convection is generally. See here, once cool air comes, hot air goes out. This is what convection, transfer of matter takes place. Yeah, convection also lead to circulation of liquid. The one more best example, you see here, in this example, what is happening when you are heating water. What happens? Sometimes you observe, once it is heated, you can see that water will be moving like this. So water will be moving like this. So what happens is when the bottom of the water is heated, it goes up, and top water will come to the bottom. So this is what the circulation process takes place. This is called best example of convection. So those are the examples of convection. And the third one is, you see, that is a radiation. It is a transfer of heat, and in this process the medium is not required. You don't require any medium. See here, you don't require anything. See here, when you are burning, even you on the stove, you put on the stove, then also water is heated. You put a head a bit slightly above the stove. If the stove is here, you put here the container, you put here, then also water will be heated, because this process is called radiation. So you don't need any matter to pass this heat from one place to another place. That is, the process is called radiation. This is the best example. See here, you can see that this flame is sending heat, that is radiation, and conduction is nothing but a rod, heat is passing through the rod. Convection is nothing but when water is boiling, you can see some it is moving like this. You can clearly see when you are doing this activity at your home also. Yeah. And in the conduction, convection, radiation, the fastest process is radiation. Fastest process is radiation, and in the radiation the speed of heat is almost equal to speed of light, that is 3 into 10 to the power of 8 meters per second. And sun's heat reaches earth due to radiation. See, this is the best example, with what speed it reaches earth. When we sit side by side, side of fireplace, we get heat, because that is also radiation. You don't require any medium. In electric bulb, the temperature of filament is nearly 27,000 degrees, you can imagine. But we don't feel the same temperature, because on the walls of the bulb, heat is transferred by radiation only, but not by conduction or convection. In conduction, what happens? The bulb also heat. If it is by conduction, the bulb also will heat up. If it is by convection, you need some open thing to put it to make it as a convection, because transfer of matter should be there. It is not by conduction or convection. The electric bulb, we get temperature that is because of radiation only, not because of anything else. So this is what the first part of heat, friends. We'll be discussing the second part of it. Till then, like our video and share our video. Like us at www.facebook.com/bfocusclasses, and subscribe us at www.youtube.com/c/bfocusclasses1, and you can reach us at bfocusclasses@gmail.com. This was the today's classes. Thank you very much, and have a nice day.